Alright guys, I'm back, like I said I would be, and here is part 2 of this same lecture series on limits and their properties and evaluating them algebraically. Okay, so Theorem 3 is very similar to Theorem 2. Theorem 2 involved basically the shortcut to finding a limit of a polynomial. This is of a rational function, which of course is a fraction of polynomials is what that is, so it's very closely related. Simply plug them in and see if you get a real number out. Okay, if you get a real number out, and I should say is equal to this, if P of C over Q of C is a real number. Okay. Now, what if it's not a real number? Well, it depends upon what it is. If you get a real number, then that is your answer. If you get infinity, all right, like 2 over 0, say, well, then you have an answer. It's simply the limit does not exist. But there is a third scenario, and we're going to see that down here. Okay, so let's look at this. We want to let's find the limit of this function as x approaches 1. So I'm going to say this. Okay, well, always start with doing what the theorem says, plug it in and see what you get. Well, if you plug this in here, this is 1 squared is 1 plus 1 is 2, 2 minus 2 is 0, all over, same thing here. That's going to be 1 minus 1, which is 0. All right, what is that? Okay, this does not equal 0. It does not equal infinity. And it certainly does not equal 1. We're used to anything over itself is 1, but nothing over nothing isn't something. I'm sorry, that was an old, I don't know, R&B song back in the 70s. Sorry, I digress. I like to laugh. If you haven't figured that out yet, I do like to have fun with this because I know this could be kind of dry, shall we say. So I do like to crack jokes on occasion. Anywho, it's neither of these. So what is it? All right, well, 0 over 0 or infinity over infinity has a special name. Is called, anybody know this? I wonder if anybody's heard this before. Indeterminate. Indeterminate means what the word implies. Indeterminate, cannot be determined. All right. What that means is there very well may be a limit. Indeterminate means it can't be determined by direct substitution, so you need to go a step further because there could be a hiding limit, a lurking limit somewhere in the function. And if you see this graphically, I think, hopefully, you can see as x approaches 1 from the left and from the right, this is what the limit should be because this is what the y values are approaching. But can you show this algebraically? And that is the bulk of the work that I'm going to be asking you to do, is to be able to show this algebraically. So let's now come over here and see. Okay, so now I'm going to come right over here and we're going to do what? We're going to simplify this. All right, so let's see what we could do. We could probably simplify this part right here. By the way, this part right here is called the argument of the limit. Okay, that's this guy right here. So can we simplify this? Yes, I think we could simplify it. One of the common ways of simplifying it is to factor it. We could factor the top and the bottom here. And if we can cancel something, then we may be able to find that hidden lurking limit. All right, so this would be, what does this factor into? Okay, and then the denominator here, I can factor out an x. And I'm left with x minus 1 as x approaches 1. Boom, those are gone. Okay, of x plus 2 all over x. And now take the limit with our new argument. Okay, and what does that equal? That is 3 over 1, which is 3, which is exactly what it looked like we were going to get from our graph. Now I want to point something out here, and I'm going to reiterate this later on as well. But do you guys notice how I rewrote limit? Started out here, yeah, but I didn't say that this equaled just this because it doesn't equal just this. Remember, limit is an operation. Okay, it means as x approaches 1. So while you still have an x here, then you haven't plugged in the 1. So while you still have an x here, you must rewrite lim or it is mathematically incorrect. Okay, so keep that in mind. That costs more points on the first exam, I think, than any other mistake. While that variable right here is still anywhere in the argument, you rewrite lim, okay, each time because you haven't actually done what it's saying. Okay, before we go on to the next example, let's do this. Let's just step back for a second and revisit example 2 and evaluate it algebraically. Okay, we already know what the answer is. We figured that out just using the table, and that the limit here should equal 6. But the key is, can you determine this algebraically? So this is great practice. Go ahead and pause the video and give it a try. This is using a technique of Algebra 2 in high school that hopefully you remember, but if not, I know we've all substance in any case, give it a try, come back and check your work. Okay, well, hopefully you got something out of it, so let's see how you did. All right, the first thing you want to do is you want to take the limit. All right, so that means plug it in. So if we plug this in, this is going to be 0 over what? Square root of minus 3 minus 3 is 0. This is indeterminate. That means there's most likely, not always, but most likely a hidden lurking limit in there. So we need to find it. We need to go and do more with it. Now what can we do here? Can we factor this? Well, your first inclination is to say no. Technically, yes, we can. All right, because I could write this as the square root squared minus 3 squared, difference of two squares, and factor it out, and I could cancel it. So I could factor this. But an easier way that you might appreciate more is to multiply top and bottom by the, what's it called? Begins with a C, conjugate. Hopefully you remember that. All right, we have a radical, it's a binomial, and so we're going to multiply top and bottom by its conjugate. Okay, so if we multiply top and bottom by the conjugate, and here is the conjugate. Remember, the conjugate of a binomial is basically the exact same terms, it's just with an opposite operation. So the exact same first term, exact same second term, change the operation. If it was minus, become plus. If it was plus, become minus. Okay? And now we're going to simplify this, but this is important. Okay, look what I did here. All right, you only simplify, only multiply the two conjugates. Okay, let me make a note here. Okay, only simplify the two conjugates. Leave the other parts side by side. All right, there's a reason for doing that. If this works out the way I believe it will, then you should be able to cancel the binomial that doesn't have the radical. All right, if you multiplied it, then you'd have to refactor it, and that would become a mess. And so always leave those just side by side, but do simplify the two conjugates. And that's very simple to simplify because whenever you multiply two conjugates, it's always the square of the first term. Okay, square root squared is x, minus, because you're multiplying two opposite signs, so it will always be minus, and then the square of the second term. 3 squared is 9. Okay, and that worked out beautifully because guess what? Now I can cancel that. All right, and that gives me lim of square root of x plus 3 as x approaches 9. Notice I rewrote lim because the variable still appears in the argument. Okay, but now I'm going to actually take the limit by plugging in that number, and that gives me square root of 9 plus 3, that's 3 plus 3 is 6, and that corresponds to what we found out earlier using the table. Now, let me explain something in a little bit more detail. I made a little note here. Why it's important to rewrite lim if the variable still appears in the argument. So what I decided to do is to make a little note on this and to give you an example that correlates to something you're very familiar with. I think the correlation will hopefully drive it home. Saying this lim of this guy, which obviously this would cancel, as x approaches 9 equals just square root of x plus 3, no limit, equals 6. Okay, saying this would be tantamount, in other words, the equivalent of saying this. Would you ever do this? This would be the same as saying square root of 4 equals 2? No. That is absolutely mathematically incorrect. It's the same thing. This does not equal this. Okay, it does equal this. I could say square root of 4 equals 2, sure. But while that x still appears, whatever that variable is, it could be an x, it could be an h, an I, whatever it is. If that still appears here, then you haven't done the operation and you need to rewrite it. Okay, it still appears, okay, you haven't done the operation here, so you would need to rewrite the operation. Okay, so let me erase that because I don't want to confuse you on this example, but that's why it's important, very important. That'll cost you points. Be careful there. Okie doke, we have 4 more examples and then we are finished with this lecture video. Okay, now we say it has an indeterminate form or is indeterminate if x equals c if the formula for f of c yields the undefined expression of this type. Now we've already seen these 0 over 0, infinity over infinity. Okay, these are your standard indeterminate forms. These are other indeterminate forms, but we really don't do much with this in Cal 1. Now in Cal 2, when we get into L'Hopital's, then yeah, we'll do a lot more with it. But right now, this is what you need to focus on. These are the indeterminates. Okay, so these next 4 problems are simply examples. This is practice of taking a limit. All right, and I believe in all of them that you will find that it is indeterminate. Okay, and I want to step back for just a second here. When you do the second problem here, okay, this will end up giving you your infinity minus infinity. Okay, so you will need to simplify this down, and I'll let you work on that part. In any case, I think you will find that all 4 of these problems will be indeterminate, and in all of them, I will give you a hint. In all 4, the limit does exist. Okay, I'm going to give you a hint. Now, I'm going to ask you to go ahead and pause the video and try working these problems out. Okay, but wait, before you go, I'm going to give you a little tool. I'm going to give you some help on something. All right. Now, obviously, this is trig, and this is approaching pi over 2. And you may have forgotten the unit circle values. Maybe you weren't strong in the unit circle. So I'm going to show you a little chart that I show all my students. I call it my little handy dandy chart because it is super easy to make, and if you can remember some basic stuff, then you'll be able to make this chart. Alright, here I'm going to create my handy dandy trig chart, which was shown to me by a colleague who was shown to her by a high school teacher, and they can often come up with the neatest ways to remember things. I used to teach high school as well, so I can relate to this. So what this chart does is it's going to give you all of the trig values for the 3 main, and both if it's the 3 main, you'll also have the reciprocal functions in the first quadrant of the unit circle. So you're going to start off with making a rectangle. Now, obviously, if you've already have these values memorized, then you don't need to worry about this, but this is for all those folks that maybe don't have them memorized. Okay, and we're going to have sine, and we're going to have cosine, and we'll have tangent. And up at the top, I'm going to have the primary angles of Q1, which is and it's going from smallest to greatest. So this is going to be 0. Okay, and then we have pi over 6, pi over 4, pi over 3, and pi over 2. Okay, now if you can remember to make this, then it's very simple. Here's what you do. All right, you see this 0, you write it down, and then write down 1, 2, 3, 4. Okay, put all of these under a square root. Now put them all over 2. Now simplify. If you can remember this, then you've got all your values. All right, this is 0. Square root of 1 is 1. This is 1/2. This doesn't simplify, stays what it is. Same thing here, but the square root of 4 is 2, and 2 over 2 is 1. So here are your values of sine in the first quadrant. 0, half, root 2 over 2, root 3 over 2, 1. If you have these, cosine is easy. They are the exact same values in reverse order. Ended with a 1, start with a 1. Next to the left is root 3 over 2. That's next to the right. This is the same value for sine and cosine. Next is 1/2, and next is 0. And how do you get tangent? It's sine over cosine. 0 over 1 is 0. 1/2 divided by root 3 over 2 is the same as 1/2 times the reciprocal. The 2's would cancel. You would have 1 over square root of 3, which I like to rationalize. That's square root of 3 over 3. Okay? Any non-zero over itself? 1. Okay, divided by a half is multiplied by the reciprocal. That's just square root of 3. And 1 over 0 is undefined, which of course is infinity. And on the graph of a tangent, that's where that asymptote would come in. Okay, in Q1, that's where that asymptote would be. Anyway, if you can remember how to make this little chart, then you will always have these values ready to access, which is what you will need for that first problem. So now, go ahead and pause the video and work on the last 4 problems, and then we'll go over them. Alrighty, let's see how you did. Okay, so first thing you want to do, of course, is actually take the limit, which means plugging in your x value. So that's tan of pi over 2 over secant of pi over 2, which you could look at your chart to know that it is infinity over infinity. Now, actually, that leads me to another point, how to remember what the reciprocal of secant is. All right, there's sine, cosine, there's secant, cosecant. It's easy, very easy to get those confused because the natural inclination is to think, well, cosine, cosecant, right? No, that's not quite right. So I have another little way of remembering. I'm all about mnemonics. You probably figured that out by now. Little shortcuts, little ways to keep this all straight, especially when you're stressed during an exam and you get it mixed up. So here's what I call my 2C rule. Okay, if you have your original function and it's reciprocal, all right, if the original is sine, its reciprocal is cosecant. Why? Because there has to be exactly 2 C's between them. There's no C in sine. There's 2 in cosecant. Therefore, that's your relationship. Same thing with cosine. There's already 1 in cosine. That means its reciprocal can only have 1. So the reciprocal of cosine is secant. Again, 2 C's, 2 C's. Okay, that's your 2C rule. It's just a little way to keep it straight in case you forget or you're not sure. Okay, so that means secant, which is 1 over cosine. And if you look at cosine of pi over 2, okay, let me come back over here. Cosine of pi over 2 is 0, so the reciprocal, flip that, that's 0 over 1, 1 over 0, which is, of course, infinity. So it is indeterminate. So I have a little hint written in here. Hint. If your argument has either tangent or a reciprocal function, either or, a good process would be to first try rewriting them as sine and cosine. Rewrite tangent and whatever your reciprocal is in terms of sine and cosine, and it'll often simplify where it'll work out. Okay, so if I do that, all right, this would be sine over cosine is tangent, 1 over cosine is secant. All right, and continuing on, dividing by a fraction is of course the same as multiplying by the reciprocal of that fraction. Well, what happens to my cosines? Boom, they're gone. That's what I wanted to happen. I was hoping that would simplify down nicely, and it certainly did. That leaves me with the limit of sine x as x approaches pi over 2, and of course that is equal to 1. All right, let's look at the next problem. Let's see how you did with that. All right, so here we have a difference in 2 fractions, 2 rational functions, which are basically fractions, okay? So this is one of those, what I would call hybrid indeterminate forms. It's not a fraction form, it is a difference form, but it is indeterminate. So what could we do to simplify this? Again, I have another hint written, okay? Hint. If your argument, or if you have the sum or difference of 2 fractions, try rewriting them as 1 fraction. Well, how do you add or subtract fractions? You need a what? A common denominator, right? You're looking for the least common denominator. You certainly wouldn't want the greatest here. That would be a mess. All right, so what is the least common denominator? Well, right here. If I took this x squared minus 1 and factored it, then I would see that both denominators have something in common, the x minus 1's. Okay, so that is common. So the only thing that makes it uncommon is this x plus 1. So the second guy has something that the other one needs. All right, so all I need to do is multiply top and bottom here by the one part that it needs to make it common. Your LCD is then going to be x plus 1 x minus 1. Now, could you have multiplied top and bottom here by x squared minus 1 and then top and bottom here by x minus 1? Well, sure, it'd make it common, but it certainly wouldn't be the least common denominator, and you would end up with a monumental mess, and it would be a pain to evaluate. In any case, we do the top and bottom here. I have my common denominator, which means I now have, this is my limit here, and 1 times x plus 1 is x plus 1, and then minus 2 all over this, and then of course 1 minus 2 is negative 1, and then once I get that, then boom, I can cancel this out. And that leaves me with 1. Remember, it's not 0 on top. You're not subtracting it. You're dividing it, okay? Any non-zero over itself is 1. Now, don't be confused. I know you're probably thinking, but wait a minute, that isn't non-zero. If you plug in the 1 here, you're right, that would make it still indeterminate, right? But remember, that's why we're leaving limit here, is we're not plugging in the 1 yet. So we simplify this as it is. Now, that would be 1 over x plus 1, then plug in the 1 and you get 1/2. Okay, now we go on to our next problem. Now, what do we have here? Well, first of all, just take the limit. That's always should be your first step. Take the limit. Who knows? I mean, it could be a trick question where it just works out beautifully, where you don't have to do any extra work. I haven't been unknown to do that in the past. I don't know if I do it now, but in any case, take the limit. Well, this is going to be 8 minus 8 over 16 minus 16, so sure enough, yes, it is indeterminate. All right, so what can we do to simplify this? Well, hopefully you see relationships here. This is a difference of 2 cubes, and this is a difference of, I know it's fourth powers, but it's also could be rewritten as a difference of 2 squares. You could rewrite this as v squared to the second power minus 4 to the second power, right? So you could rewrite it as such. Now, difference of 2 cubes. You may have forgotten that formula. All right, I have written over here the formula for the difference of 2 cubes. All right, a cubed minus b cubed is a minus b, parentheses, times a squared plus ab plus b squared. By the way, just a side note, I just want to point out to you here in the back of the textbook, if you happen to have a hard copy of the textbook, or online for that matter, if you look at the back of the textbook, you will have a formula chart on algebra. Here's your special factorizations. You will also have information on, next page here, on trig, on all the different trig identities and whatnot, in case you've forgotten that. And we go into the calculus part as well, which we'll deal with that a little bit later on. In any case, if you have a hard copy, you could take it out of that book. If you have an online copy, you might print it just so you have a copy handy with you. So let's see here. All right, well, here is our formula. So now let's rewrite this difference of our cubes using this formula. All right, so that means that, okay, v cubed minus 8 implies that your a here would be v and your b would be 2, because it's the roots of these two terms. So the cube root of v cubed is v. The cube root of 8 is 2. Now you may be thinking, well, wouldn't it be negative 2? No, that's where this formula comes in. All right, there's a separate formula for a sum. So you would just simply get the values here, would take the cube root of the first term, the cube root of the second term. That operation between them would simply determine which formula you use. Okay, so if that's the case, we're going to come over here, and that would be v minus 2 times v squared minus 2v plus 4. Nope, my bad. That should be plus 2v plus 4. All right, and then I can then factor this out. This is the same as v squared minus 4v squared plus 4. Okay, multiply that out would give me my original denominator. Now, can I do anything with it yet? No, I could take the limit, but I think you would see that it's still indeterminate. So what can I factor now? Well, I still have a difference of 2 squares. So let's factor that again. So this would be v plus 2, v minus 2. And that worked out nicely, because guess what? Now I could knock this out. And that's what was making this thing go to 0. So now I bet that, this again too. So now I bet this is probably going to, see, I had it fixed here, going to work out. Okay, so if you plug this in, this is 4 plus 4 plus 4 all over 4 times 8, which is 12 over 32, which reduces to 3/8. And here is our final problem of this section. Now, number 38 is very similar to example number 2 that we revisited, okay, where we have a binomial and we have a radical in it. All right, so first things first though, take the limit, make sure it is indeed indeterminate because it may not be, but of course this one is once you take the limit. So let's multiply top and bottom by the what? Conjugate, right. We're going to do the conjugate here, and again, it's just the radical, opposite sign, and then the same term here. Okay, so here we're multiplying top and bottom by the conjugate. Let me at this point stop. I want to say something to you that will hopefully save you losing points. Okay, a lot of people think, or a lot of students think, it would be really easy just to square top and bottom whenever you have a radical involved, right? Absolutely not. You cannot do that. Now, why not? Squaring would actually change the problem. You could square it if you had an equation out of it, okay? Then you could do your different operations on one side, both sides. But when you're dealing with an expression, the only, and let me emphasize, the only way to modify it is by multiplying it by 1. Multiplying anything by 1 does not change the problem, which is why we have to do this. Now, you can also factor, obviously that's canceling, that's dividing out. That's just simplifying and dividing. But as far as multiplying or squaring, you cannot square. You can only multiply by something that is the equivalent of 1. Okay, so again, like before, like I said, whenever you're multiplying a binomial by its conjugate, simplify the two conjugates. Do not do anything with the other terms, okay? Because we want one of these other terms to cancel out. And really, it's the one that goes to 0 down here. This should go away. And looks like it should. So this conjugate, square root squared, the square roots would simply go away. You're left with the radicand, which is x squared plus 8. All right, it's always going to be minus because you're multiplying opposite signs. And then it's the square of the second term, which of course would be 9. 8 minus 9 is negative 1. So that's going to give you x squared minus 1 all over our denominator. And then what can I do? It's still indeterminate. But here I can certainly factor this, difference of two squares. Okay, so we're getting close. I'm going to take all this down here so you can see the whole thing. So this is x plus 1, x minus 1. And then that means that those guys do cancel just like I was hoping for. And that leaves me with my x minus 1 over my root of x squared plus 8 and then plus 3. And now take your limit, plug in the numbers, don't need to rewrite limit. That gives you negative 2 over 6, which is negative 1/3. All right, so hopefully all that made sense to you. And as always, if you have any questions whatsoever, please feel free to let me know while you're working on this. And yes, while you are working on the homework problems, if you do have questions on them, my advice is to do what a few students have already done, and that is take a screenshot of the problem on which you're working and send it to me in an email with your questions. I can then look at it and I can immediately write back to you. That's a lot quicker than sending me a message through Achieve using the Ask My Professor function, because I'd have to be at my computer to do that, whereas on an email, if I'm out somewhere, I can see it on my phone and help you out much more quickly. Anyway, take care, guys. Talk to you soon. Bye-bye.